Hello students, how are you? I am Manoj sir from AP. Today I am going to discuss one important topic, number system. Okay? So number system today I will discuss. First I want to say which points I will discuss today. First point is learning objective. That means why we will learn this topic. Is it clear? Second point, different types of numbers. Third point, rational numbers and its standard form, including equivalent rational numbers. This is our third point. Now fourth point, representation of a rational number on a number line. Is it clear? And fifth point, insertion of rational number or numbers between two given rational numbers. I think this part is clear. So today I will discuss these 5 points one by one. Please follow my class. Now first point is learning objective. Students, we use various types of numbers in our real life situation. Yes or no? Please see here. Here picture of birthday cake. From this birthday cake, from full parts, some part is taken out, and this 1/4 portion here and half portion is here. So what we are seeing here, two numbers, 1/4 and 1/2. Again see here one measuring glass. What we are observing here, 0.25, 0.5, 0.75 like this. So this is one kind of number. So these are one kind of number. Again see, these are the house points. I think you know in your school house points. So house points are represented by numbers, say 100, here 130, 145, 100. So these are also one kind of numbers. See here, we are using various types of numbers in our real life situation. Yes or no? Now see another type of numbers. See here, when temperature goes down, that is below 0, then we are getting negative. So here temperature is showing in the negative parts when temperature goes below 0. So -20, -40, -30 like this, -10 also. Is it clear? So here we are using negative numbers. So this is one kind of numbers. Again see here, to solve the equation x square equal to 2, we write x equals to plus minus root over 2. So this is also root over 2, this is also one kind of number. Students, see, understood, see what types of numbers we are using in our real life situation, various types of numbers. So today we will discuss this number system. Is it clear? Now see this chart. Please follow this chart. This is the real number chart. We'll follow from the last. That means we'll proceed from the last here. We'll proceed from the last portion. That means from below to top we'll move. See here, natural numbers or positive integers or counting numbers. Yes. We have learned the first numbers, these numbers. These are called counting numbers. In our childhood, we have learned these numbers. That means counting numbers. To count the things, number of things. Say 1 ball, 2 pens, 3 books. So 1, 2, 3, 4, 5, 6 and so on. These are positive integers or counting numbers, or we can say natural numbers. Then 0 included in this group, then we are getting whole numbers. So when 0, this number is included in the natural numbers, then we are getting a new number system that is called whole number. Yes? Now, with this whole number, when we are adding negative integers like -1, -2, -3, -4 and so on, then we are getting a new number group that is called integers. Yes or no? Now see, here non-integers numbers also. Non-integer numbers means under non-integer numbers we are getting two types of number, decimals and fractions. Again decimals, here we are getting two types of decimals, terminating and non-terminating but repeating, that is called recurring decimals. Say 0.15, 0.1, 0.86, -2.5, all these are terminating, and 0.333, 0.131313, that is recurring decimals. Yes? So under non-integers we are getting two parts, decimals and fractions. Clear? So now if we combine these non-integers and integers, then we are getting a new number system that is called rational numbers. Is it clear? Again see in this chart another number, that is irrational numbers also. Irrational numbers which cannot be expressed in the form of p by q. So if I give one example of irrational numbers, say √2, √3, all these are pi, e, all these are irrational numbers. But under irrational numbers, again see decimals, non-terminating and non-repeating decimals. So non-terminating and non-repeating decimals also irrational numbers. Is it clear? Now rational number and irrational numbers, if we combine these two, then we are getting real numbers. So this is the total number system. I think this part is clear. Now so we have learned first natural numbers that denote by n, standard symbol, 1, 2, 3, 4, 5 and so on. First we have learned this number. Then we got whole number, adding 0 in this group. Yes? Next we got integers. Say -3, -2, -1, negative integers when we are adding in this group, we are getting a new number system, that is integers. Yes. Again, non-integers that in this group -3/4, 0.25, 1.333 like this, that is recurring decimal, terminating decimal, fractions, yes or no? So all are non-integers group. So integers and non-integers, if I combine, then we are getting set of or group of rational numbers. Yes, rational numbers. Then irrational numbers, and finally when we are combining rational and irrational, then we are getting real number systems. Real numbers. Is it clear? So we have learned various types of numbers which we can use in our real life situations. Is it clear? So now I'll discuss the second point, rational number and its standard form, including equivalent rational numbers. This is our second point. So I have discussed learning objective, I have discussed different types of numbers. Now I am going to discuss third point, rational numbers and its standard form and equivalent rational number. So what is rational number? A number which can be expressed in the form of P by Q. Which can be expressed in the form of P by Q, where P and Q are integers and Q not equals to 0. So if the definition of a rational number is this, then according to this definition, 3/4 minus 3/6, 12/5 minus 7/-8, 2 minus 1, all these are rational numbers. Yes, because 3 and 4 integers and 4 not equals to 0, minus 3 and 6 integers, 6 not equals to 0, 12, 5, see, P and Q are integers all cases. Here this is 2 means 2/1, minus 1 means minus 1/1. So this is also rational number. Yes or no? Is it clear? Now what is the criteria for standard form? A rational number will be in standard form if P and Q are co-prime and Q must be positive. Is it clear? So when we are checking the given rational number in standard form or not, first we have to check the denominator positive or not, then we will check P and Q are co-prime or not. If these two conditions satisfy, then the given rational number is in standard form. Okay? So if I take 4/6, this rational number, it is not in standard form because Though 6 is positive, but 4 and 6 are not coprime. Coprime means they have no common factor other than 1. Excuse me. So 4 by 6 is not in standard form. If we want to express in the standard form, it will be 2 upon 3. Yes? Similarly, 8 by minus 7. If I consider this rational number, it is not in standard form. But if we want to express in the standard form, we have to write like this. Is it clear? Now, equivalent rational number. We can find many rational numbers which are equivalent to a given rational number. Yes? How? Suppose 5 upon 6, if I take this rational number, then how can you find its equivalent rational number? Multiply both the numerator and denominator by the same integers, same integral values. Say if I multiply by 3, then 15 upon 18, this rational number is equivalent to this. If I multiply by minus 1, then minus 5 upon minus 6. This is also equivalent rational number of this. So we can find equivalent rational number as many as we want for a given rational number. I think this part is clear, students? Okay. So now one example. Find out the rational number which is in standard form. 6 by 8, tell. Is it in standard form? Obviously not, because 6 and 8 are not coprime. Because I am seeing here 2 is the common factor. So that's why they are not coprime. So this is not in standard form. 7 upon minus 8, it is also not, because denominator is negative, but it should be positive. 3 by 4, 3 and 4 coprime, 4 is positive. So yes, it is in standard form. Minus 9 by minus 5, not in standard form because denominator is negative. Clear? Now example 2. What is the sum? Find out x and y if 5 by 6 equals to 20 by x equals to y by 42. So we can solve this sum using the concept of equivalent rational number. Just now we have learned it. Yes or no? So 5 by 6 equals to 20 upon x. 20. How came? 5 multiplied by 4. That is 5 into 4. So obviously 6 into 4 we have to do. So x value will be 6 into 4, that is 24. Very simple. Now y. 5 upon 6 equals to y upon 42. See 42 here and here 6. From 6, 42. That means 6 multiplied by 7, 42. So since 6 is multiplied by 7, so 5 should be multiplied by 7. So 5 into 7, that will give the value of y. That is 35 will be the answer. Yes. Now I'll discuss next point, representation of a rational number on a number line. How can you represent a rational number on a number line? That I'll discuss now. So third point completed. Fourth point, I'm going to discuss representation of a rational number on a number line. Now I'll discuss representation of a rational number on a number line. So how represent a rational number on a number line, that I'll show. For example, say 3 by 4, I have to take. Three by 4 I have to take. Three upon 4 I have to represent on a number line. So what is step 1? Step 1, we'll draw a number line like this, and we'll consider O, which is origin, that means 0. Now 3 by 4 I have to represent on this number line. So 3 by 4, its value is less than 1. So first I'll mark this is 1. So 3 by 4 obviously will be in between 0 and 1. But where? Since the denominator is 4, that means we will divide this 1 length into 4 equal parts. Say 1, 2, 3, 4. So 3/4 means this position. So this point is the representation of rational number 3 by 4. Now I am taking one more example. Say 37 by 4. How will represent it on the number line? So this is a number line and this is origin. 37 by 4. That is, it is a 1/4 of 37. So if I mark a point on this line, and from origin to this point total length is 37, and we have to mark 37 by 4, that is 1/4 of 37. That means if we divide into 4 equal parts, so this point represents 37. So I am dividing into 4 equal parts, 1, 2, 3. And 37 by 4 is 1/4 of 37. So 1/4 of 37 is this part. Yes? Is it clear? This will be 37 into 2 by 4. 37 into 3 by 4 and 37 into 4 by 4. 37 into 4 by 4 means 37. Is it clear? Now I am taking one negative number. Suppose minus 3 by 4. Minus 3 by 4, I will represent on a number line. Again I am drawing one number line. I am marking this point as origin. Now minus 3 by 4. So this value will be in between 0 and minus 1. Yes or no? So that means if I mark this point as minus 1, and we have to divide into 4 equal parts, say first dividing into 2 parts, then again this. Is it clear? 1, 2, 3, 4. Clear? So minus 3/4, that means this position will be minus 3 by 4. Is it clear? So like this we can represent different rational numbers on a number line. Now I'll discuss the next point, insertion of rational numbers between two given rational numbers. Item is insertion of rational number or numbers between two given rational numbers. So fourth point completed, and this is our last point that I will discuss: insertion of rational number or numbers between two rational numbers. There are three methods. I will show three methods one by one. So first, method 1. Suppose A and B are two rational numbers. First, we will find the average of two numbers, that is A plus B by 2. And if you mark this value by X, then we will see A less than X and less than B. But here, remember, when we are taking two rational numbers A and B, here A is less than B. Yes? So, in between A and B, one rational number X, that is A plus B by 2, inserted. But if we want to insert more, suppose one more we have to insert, then what we'll do? We'll find the average value of A and X, that is A plus X by 2. And suppose it is Y, then A less than Y less than X. Yes? If I want one more, then we'll find the average of B and X, that is B plus X by 2, and if I mark that by Z, then X is less than Z and Z is less than B. See, that means between A and B, three rational numbers are inserted. So like this, we can insert many more rational numbers between two given rational numbers. I think this part is clear, students? Now take one example. It will be more clear if we solve one sum. Insert two rational numbers between 3 by 4 and 5 by 6. So here two numbers 3 by 4 and 5 by 6. Which one is more? Identify. How we can identify out of these two numbers which one is more? Take the LCM, or we can check by cross multiplication. 6 into 3 18 and 4 into 5 20. That means 5 by 6 is greater than 3 by 4. Yes or no? Other method, take the LCM, 4 and 6. LCM is 12, so 9 by 12, and here 10 by 12. So 10 by 12 is more than 9 by 12. So 3 by 4 is less than 5 by 6. We have to insert two rational numbers. The first rational number will get how the average of these two, that is by 2. 3 by 4 plus 5 by 6 by 2. Simplifying, what result we are getting? LCM just now I told 12, 9 plus 10, and here 2. That means 19 upon 24, one rational number inserted between these two. But one more. Then 3 by 4 plus 19 upon 24 upon 2, average of these two rational numbers. That means LCM is 24, yes or no? Then 18 plus 19, simple addition of fractions. So 37 upon 48, yes, 24 into 2. So 37 upon 48, this is another rational number which is inserted between 3 by 4 and 19 by 24. So therefore 3 by 4 is less than 37 upon 48 is less than 19 upon 24 is less than 5 by 6. So two rational numbers, this one and this one, are inserted between two given rational numbers 3 by 4 and 5 by 6. Students, I think this part is clear? Yes? Okay. Now, example number 4. Insert 5 rational numbers between 3 by 7 and 5 by 14. We have to insert 5 rational numbers. But if we follow the previous method, then it will take huge time. So that's why we'll follow another method. This is a very easy method. Please follow it. So method 2, to insert rational numbers between two given numbers. What is it? First, we have to make the denominators of two rational numbers same. If same, then no need to do. But if they are not same, we have to make denominators same. This is the first step. So here 3 by 7 and 5 by 14. 7 and 14 LCM is 14. So that means these numbers implies 6 by 14 and 5 by 14. Yes. So from here it is clear 6 by 14 is more than 5 by 14. That means 5 by 14, this number is less than 3 by 7. Clear? So step 1, you have to make the denominator same. Step 2, now take the difference of numerator 6 and 5. Here difference is 1. So if I see the difference is 1, then see how many rational number you have to insert? 5. So that plus 1, one more, that is 5 means 5 plus 1, 6. In generalized form, if n rational numbers we have to insert, then n plus 1. By n plus 1, that means in this case by 5 plus 1, that is 6, we have to multiply numerator denominator of both the numbers. That means 6 multiplied by 6. Why 6? Because 5 rational number, 5 plus 1, 6. So 36 upon 84. Similarly here 5 into 6, 30, and here 84. Yes. This number is equivalent to this. This number is equivalent to this. After this, very simple. So first we will write the smaller value 30 upon 84. Then we will increase the numerator by 1. So 31, the next 31 upon 84, the next rational number, 32 upon 84, next 33 upon 84, next 34 upon 84, next 35 upon 84, and next 36 upon 84. See, 1, 2, 3, 4, 5, exactly 5 rational numbers are inserted between these two numbers. But when we are leaving answer, we can't leave it here. We have to simplify more. 30 by 84, simplest form is 5 by 14. 31 and 84. Further simplification not possible, but here 32 by 84 possible. By how much? By 4. Yes or no? By 4 if I cancel 8 and here 21. 8 upon 21. This is by 3, 11, 28. Yes, it is by 2, 17 upon 42. It is by 7, 5 upon 12. And it is 3 by 7, cancel by 12. So between 5 by 14 and 3 by 7, these 5 numbers, these 5 rational numbers are inserted. See how much easily we can insert by this process. Yes or no? Now example number 5. We have to insert 3 rational numbers between half and 3 by 4. So already we have learned 2 methods, but now I'll discuss method 3. This is another method we can apply to insert 1 or more rational numbers between 2 given numbers. What is the process here? Here also first we have to identify out of 2 given numbers which one is greater. So half and 3 by 4, that means half means 2 by 4 and that is 3 by 4. So 3 by 4 is more than 2 by 4. So here we have to find the difference of 2 numbers. That means if A and B are 2 numbers, given numbers, then we'll find B minus A. Obviously here B is greater than A. Yes. After finding B minus A value, we'll divide by n plus 1. What is n? Now if we want to insert n rational numbers between A and B, then we have to divide B minus A upon B minus A by n plus 1. Yes. So B minus A upon n plus 1, if you denote by D, then A less than A plus D. A plus D is less than A plus 2D. Like this, A plus ND and less than B. That is between A and B, A plus D, A plus 2D, like this, A plus ND. N rational numbers are inserted between A and B. Is it clear? So if we follow this method for this sum, first we will find B minus A. What is B minus A here? 3/4 minus half. That means 3/4 minus 2 by 4. That is 1/4. Yes. So A plus D value, that is half plus 1/4. Half plus 1/4. B minus A value 1 by 4. Yes. So D value is B minus A upon n plus 1. N here 3. That means 3 plus 1, 4. That means B minus value is 1/4. So 1/4 by 4. 1 upon 16 the value of D. Yes. So 1 upon 16 the value of D. Half plus 1 upon 16 means 8 by 16 plus 1 upon 16, that is 9 upon 16. Yes. So this is the value of A plus D. Now next number if we want to get 9 by 16, if we add again D value or A plus 2D, anyone you can do, that is half plus 2D. D value is 1 by 16. Yes. So 1 by 2 plus 1 by 8, that is 4 by 8 plus 1 by 8. Yes. that is 5 by 8. Another number. Yes. Next, one more, that a plus 3d, that is half plus 3 into 1 by 16, that is 8 by 16 plus 3 upon 16, that is 11 upon 16. Yes. So that means finally we are getting half less than 9 upon 16, less than 5 by 8, less than 11 by 16, and less than 3/4. So these three rational numbers are inserted between half and 3/4. Is it clear? So this is example number 5. So I have discussed three methods to insert rational numbers between two given numbers. Yes, student? So now I am ending my class here. Still, if you have any queries, you can contact me through my mail ID, that is monoj@tigps.in. Thank you, students. Have a nice day, and please watch my next video to get more interesting sums on this topic. Thank you, students.